everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt and today we are going to solve the problem mean problem from CodeChef, which is of simple difficulty level and it is an ad hoc problem. So let's have a look on the problem statement first. We are given a sequence A and its first n elements. The ith element of this sequence is generated by the following formula, and the formula is we have to find the floor of the mean of last n elements of the sequence. That is, if we have the sequence as a1, a2, a3 to an, then for calculating the a of n plus 1, find the mean of first we will find the mean of the last n elements preceding it, that is a1, a2 to an. And for calculating the a of n plus 2 element here, we will find the mean of the next n elements after a1, or we can say the last n elements which is preceding it. And for finding the an plus 3, we are going to find the mean of a3, a4 to an plus 2. And now what is our task is we have to answer some queries in which we will be asked to tell the exact element of the sequence. So let's have first look on the input format of the problem. The first line is going to contain the number of test cases. The first line of every test case is going to contain an integer n, which is going to give us the size of the sequence, and then the AI value will follow. Then the next line is going to give us the capital Q, which is the number of queries here. And then for the next Q lines, we are going to have an integer x, in which we have to tell that what is the exact element of the sequence. Now for the output, for every query, we have to output an integer that is denoting the value of the corresponding element of the sequence. In the constraint parts, we have t value lying between 1 and 10, n value in the range 1 and 10 to the power 3, ai value in the range 1 and 10 to the power 3, q value in the range 1 and 10 to the power 5, x value in the range 1 and 10 to the power 9. So this means in the worst case, we could have been asked with the 10 to the power 9 element. So let's see how we can solve this problem. So this problem is on the first side simple to do problem, like we are going to calculate for every index. Like for a given index, we have to generate the sequence up to that point and we have to simply output that index. But here if we see that index can be up to 10 to the power 9. So it is not possible to go to the 10 to the power 9 index, else it will give us the TLE. So we need to have a basic observation for this problem. And that observation was the elements of the sequence will become constant after certain number. Now why is it so? Let us assume that we have an sequence a1, a2 to an in which every value is same, let's say equal to m. So the maximum element is m here, and when we will be calculating a of n plus 1 element, we will be calculating the sum of last n elements preceding it, that is a1 plus a2 to an. So we will have n times m here, and then we will be calculating the mean of it, so it will come out as m. So an plus 1 element will come out as m here, and when we will be calculating a of n plus 2, it will again come out as n, because again the sum is going to be n into m. So this sequence is going to be constant for always. This is the case when our initial sequence was all equal, was having all values equal. So let's consider the case in which our sequence is not equal, that is the every value of sequence was not equal. So in this case there will exist some maximum, and there will be some value which will not be equal to this maximum, and that value will definitely be less than this maximum. So when we will be finding a of n plus 1 element, we will be calculating the sum of the last n elements. So in this sum, we know that not every element is equal and the maximum one is m, so the sum is definitely going to be less than this n into m. So our sum is going to be less than n into m, and when we will find the mean of that, it is going to be less than m. So what I'm saying basically, the maximum value is going to be less than m. So now for every chunk of the elements, we are getting reduced with the value, and m value can be up to 10 to the power 3. So after 10 to the power 3 into n elements, we can claim that all of the elements will become constant after that. So we have reduced the complexity of our program from calculating the 10 to the power 9 element to 1000 into n elements. So here it is also the fact that we can't always calculate 10,000 into n elements for every query. We can have a case in which our q value is 10 to the power 5 and n value is 1000, and we have 10 to the power 5 query which is asking us to calculate the 1000 into nth element. So in this case our code will give TLE. So we have to do some kind of pre-computations to avoid this situation. What we have to do, we have to pre-compute our sequence of 10 to the power of 1000 into n elements, and when we will be encountering the query and we are asked to find the kth element of the sequence, then we will check that whether this kth element is lying in the sequence of first 1000 into n elements. If it is lying in n, then we are simply going to access that element from the sequence in O of 1 time. And if it is not present, then we are going to print the last element of the sequence, because we know after that the elements are going to be constant. So in this case, what we will do, we will print the last element of the sequence and it will also take O of 1 time. So we are answering our every query in O of 1 time. So this will not take much time. Now the major factor remain is pre-computing. Now the next challenge in this problem is pre-computing the sequence efficiently. So we know by the definition that for calculating the aith value, we have to find the mean of the last n values that are preceding this element. So let's understand it better by taking the sequence as a1, a2 to an. Let's say we have to find the a of n plus 1 element. Then for finding it, what we will do, we will find the mean of last n elements that are preceding it. So for this, what we will do, we will calculate the sum of the last n elements and then we will divide it by n. And then for calculating the n plus 2, we will again do the same thing. We will take the last n elements preceding a of n plus 2, which will be a2, an plus 1, and then we will be dividing it by n so as to find the mean of those values and assign it to a of n plus 2. Now what we are seeing is for every element we are assessing its last n elements. So this will take the number of elements into n operations, and we know that we have to find at most 1000 into n elements roughly, that is an upper bound. So this will definitely become greater than 10 to the power 8 operation, and we will get the TLE due to this fact. So now the basic observation what we can see here is, while we are calculating the sum for a of n plus 2 element, it is none other than the sum for a of n plus 1, sum for a of n plus 1 minus a of 1 plus a of n plus 1. That is, for this chunk we are using the previous chunk of it and we are simply removing the oldest element from that, and we are adding this new element for calculating the sum of the new chunk we are forming. So this will take O of 1 time to calculate the sum of the last n elements efficiently, and this will bring our operations down to n. So this will take simply O of n time, and here the n value will be 1000 into n, so that will be enough for us to get calculated under the constraints of the time. Now let's have a look on the C++ implementation of the code. Here the first two lines are the fast input output, and then we are taking the input of t test cases. Then for every test case, we are taking the input of n, that is the size of the sequence, and then we are taking the input of first n values, and at the same time we are calculating the sum. Then for the n elements, then we are assigning the number of elements we want to pre-compute in the sequence as the capital N, and then we are finding the rest of the elements of the sequence, and we are doing this thing here so as to get the sum of the next chunk in O of 1 time. And then we are taking the number of queries as input, and then for every query we are taking the input of the number of element we need to find. Then we are simply reducing it to the zero based indexing because our first element is stored at the zeroth index of our vector, and then we are assessing the last element of our sequence as a dot back. If the element was in the first capital N calculated elements, then we are simply assessing that from the sequence, and else we are printing our answer to the screen which was assigned with the back of the sequence, because we know that its value is greater than, because we know that it is greater than or equal to n, and it is going to repeat the back element only. So let's run this on the basic sample input. So here we can see that it is exactly same as sample output. So let's submit it and check whether it gets passed or not. So here it is showing the correct answer. So let's have a look on the Python implementation for the problem. Here we are doing this thing so as to get the fast input output in Python. We are taking the t test cases input, and then for every test case in the range of 0 to t, we are taking the input of n value, that is the size of the sequence. Then we are taking the input of values of the sequence, and then we are finding the sum of the first n elements, and then we are simply assigning the number of elements we want to have in our sequence in the capital N, that is 1000 into n, and then we are iterating for the rest of the elements we need to calculate here. Now we are taking the input of q, that is the number of queries. Then for every query we are fine, and then we are reducing the index of the element by 1 so as to get it back to the zero based indexing. And then we are assessing the last element of the sequence. If the element we need to find lies in the first n elements, then we are simply assessing it by the pre-computed sequence, and we are outputting this answer. And if this element is not existing in the first capital N elements, then we are simply assigning our answer to the back of the sequence, because we know that the elements after that is going to repeat itself. So on running on the sample test cases, we can see that 232 is same as the sample output we are provided in the problem. And on submitting the code, we can see that we are getting the correct answer. Now the common mistake we can encounter in this problem is we are not reducing the index by 1, and we have stored the elements in the zero based index, but we are assessing the elements from the 1 based indexing point of view. The other thing we could have here is we are not using the fast input output. We have to make sure that we are using the fast input output in the specified language, because here we need to print 10 to the power 5 values, and this, if our input output method will be slow, then it is going to give us the TLE. So we have to make sure that we are optimizing our input output methods. So that's it for the video, guys. Thanks for watching.